Hi, everybody. This is Andrew Shikyar, serve as FIDO's Executive Director and Chief Marketing Officer. Hope you've been enjoying today's Authenticate Virtual Summit on FIDO Device Onboard. Moving forward, very pleased to introduce to you two speakers from Red Hat. We have Costin, Gament and Vitaliy Emporopulo to talk about how Red Hat uses FDO in device lifecycle. So Vitaliy will kick things off. Vitaliy.
Thank you, Andrew. Hello, my name is Vitaliy Emporopulo, and today with my colleague Costin Gament, we are going to talk about how Red Hat uses FDO in the device lifecycle. We are not going to show a demo, but rather share our vision, the tools we build around FDO, and talk about Red Hat's implementation of FDO. So we recognize three phases in the device lifecycle here at Red Hat. Day zero is device onboarding. Obviously, FDO is good for secure device onboarding. And we have our own implementation of FDO, which is part of Red Hat Enterprise Linux, starting with 8.6, and today it's 9.3, the GA version. The next phase is day one. It's device customization. We use OS3, a technology called the OS3, for switching to a custom operating system, and that operating system can be tailored for a particular device role or a particular customer. Here we can use FDO to trigger that deployment of that custom operating system using OS3. Day two is device management. We use Ansible automation platform, or AAP, for managing device configuration, updates, and so on. And here again, we can use FDO to automatically add a device to an Ansible inventory upon onboarding so that it can be later managed by Ansible. You are familiar with this diagram. It comes from the FDO specification, and I'd like to focus on how Red Hat's implementation addresses the spec. So we have a manufacturing server on the manufacturer side. We have a rendezvous server. We have an onboarding server, a service info API server, and two clients and initialization, which goes with the manufacturing, and an onboarding client. The service info API server is a separate software component at the moment, and it manages actions that run when onboarding devices, and uses what's known as FSIMs, FDO service info modules. So as I mentioned, these are the components we implemented Red Hat, all the four types of servers, the initialization and onboarding client. We also have CLI tools, an administrator tool, and an owner CLI tool. As I already said, these implementation is included in Red Hat Enterprise Linux. It is written in Rust, so very efficient. Of course, it is open source, Red Hat, and it is under active development. Here is a more formal diagram of the FDO implementation, with a focus on the components and the relationship between them. As you probably know, the primary Red Hat's platform for running containerized applications is OpenShift Container Platform. It is based on Kubernetes with additional enterprise features such as enhanced security, observability, etc. And one of the methods for packaging, deploying, and managing Kubernetes applications is the operator. So we have developed an FDO operator. That operator allows for easy deployment and management of FDO services on OpenShift. Here, what it looks like when you deploy the operator, you can install it from the operator hub. After adding the right catalog source, it supports three custom resources: a manufacturing server, an onboarding server, and a rendezvous server. As you might have noticed, there is no Service Info API server because it is packaged together with the owner onboarding server. So right now they are both part of the FDO onboarding server. It addresses both the manufacturing and the owner side of FDO. Of course, you can run both of them on the same OpenShift cluster if you want like testing or development. It's very convenient. And if you are an Ansible shop, we have an Ansible collection as well. Here is what a configuration a sample configuration looks like. It is actually the one that supports the lifecycle stages I mentioned in the first slide. In addition to creating initial users, injecting SSH keys, it has a file section. That the file section is actually makes sure that those files specified in this configuration are copied over to the device, and then the command section actually runs commands to make sure that use those files to make sure that the stages are actually executed. And at this point, I will hand it over to Costin, and he will tell about this in greater detail. Over to you, Costin.
Thank you, Vitaliy. So we've mentioned operating systems. We all know Red Hat Enterprise Linux is the leading OS for servers. But what can we do at the edge? What are our needs for the edge devices? Well, first of all, we would like different OS images to handle different roles, different types of workloads. It would be really nice to be able to manage and deploy many devices at scale, thousands or many more. It is also very important at the edge to have efficient and intelligent over-the-air updates and rollbacks in case something goes wrong. We've managed to fulfill all of these requirements and package them into something called Red Hat Enterprise Linux for Edge. And one of the core technologies for that is called libOS3. So what is libOS3? It's a shared library and suite of commands that combines a Git-like model for committing and downloading bootable file system trees. This is the formal definition on the left-hand side, but what does it really mean in practice? Well, first of all, it's an immutable operating system. That means you cannot directly change operating system files. It provides an interface for very easy updates, upgrades, and rollbacks. All these operations are automatic and incremental. That means we're using minimal bandwidth usage for updates. So if you're somewhere remote, you will just get over the wire just the bits that you need to perform your upgrade, nothing more, nothing less. And also another key feature is that it provides a very simple procedure to change operating systems. What do I mean by this? Well, it's a single command. This is the command. It's called a rebase. It's done via our utility rpm-ostree, which just bridges Red Hat package management with OS3 image management. And you will notice that the image I'm deploying with this command, it's actually an OCI container image. So that means it can live in a standard Docker registry. and the whole operating system is encapsulated in this OCI container. We've also mentioned Ansible automation platform. So after we switch to the new OS, we would like to configure it somehow. Ansible automation platform is based on Ansible configuration management tool. It's important to note it's agentless. It runs over SSH, so you don't need to run a new daemon on your host. And it runs as an OpenShift operator, which adds this very nice UI you see in the image here. For example, when you're after you're onboarding or registering a new device to Ansible automation platform, this is how it looks like. You just have an ID, a unique ID for your device, and an IP where Ansible automation platform can SSH to. And at this point, you can run whatever playbooks or inventory you want on top of this. Another direction we're exploring is integrating FDO and OpenShift Assisted Installer. What is OpenShift Assisted Installer? It's a way to deploy OpenShift clusters on bare metal by booting a discovery ISO we're building for each cluster. FDO can be used to verify the cluster nodes and then start the installer agent. This helps us to remove the secrets and other sensitive data that's in the discovery ISO, and everything is moved to the service info server. So it's completely under your control. Thank you very much. These are some resources. As Vitaliy mentioned, everything is open source. So if you have any contributions, questions, comments, please feel free to access these links. And I think we can take some questions now if there are any. Thank you.
Yeah. Super. Thanks, gentlemen. That was very interesting, informative. Yeah, please send any questions in. Here's one. Can the device credentials be stored in TPM?
Yes, there is actually. Costin, are you going to?
No, go ahead, Vitaliy.
Yeah, okay, thank you. There is actually a draft specification for TPM and FDO, and in this case, the process is essentially the same. The device will be booted into an FDO-enabled ISO, and the onboarding client will recognize that there are device credentials and kick in and proceed with the onboarding. So this doesn't change the process too much.
Okay. Do you mind going back to that last slide with the resources again? So again, yeah, so we'll send these links and slides out following, but if anyone wants to look into this, here's some very actionable resources for you from Red Hat.
Yeah, actually, you can just access there is, as you can see, there is a single GitHub organization that actually hosts the tools around FDO. We try to keep them together. It's FDO-RS, and that includes the implementation, the operator, the Ansible collection.
Excellent. Okay, so I don't see any more questions. So I'd like to thank again Costin and Vitaliy for their time today. Thank you, Red Hat, for the presentation.
Thank you for having us.
Thank you.